Hello, I'm Mr. Craig, and I want to talk about polyatomics today. So let's take a look at the homework here. First of all, there is a list of polyatomic ions that I've given you within your notes. One thing I don't want you to do is look at this and think, oh, do we need to know all these? The answer is no. However, there are a few that you should know. And let me blow this up a little bit here. So the first one is acetate. Make sure you know acetate. And then we have chlorate, ClO3, so that's the second one. The third one, pretty common, hydroxide, which is OH with a -1 charge. And notice that all of these have a -1 charge. The fourth one is nitrate with an NO3 with a -1 charge. And I believe there's one, nope, that was it. So again, from this row, you've got your nitrate, your iodate, your hydroxide. Oh, I may not have mentioned iodate. So iodate, IO3 with a -1. The hydroxide, so that's 3. Chlorate, ClO3. And then acetate is the first one there. Okay, so those are 5 from group 1A. And make sure that you have those polyatomics formula and charges memorized. So what that means is you don't need to know the other ones. The reason why I gave you the other ones is because when you get to college, you may want to reference this again, and this is not the list of all the polyatomics that actually exist. All right, so let's look at the -2 charges, the ones that I want you to know. The first one from the -2 column is carbonate, CO3. The next one is chromate, so there's 2 there. And then the third one is sulfate, which is right here, SO4 with a -2 charge. And I believe that's the only one there. So there's 3 out of that one. So again, the 3 that I want you to know from -2, sulfate, chromate, CrO4 with a -2, and carbonate, the -2 charge as well. And then from the -3 side, there's only one of those that I want you to know. Whoops, get it over here. And that would be phosphate. So let's move you over. So phosphate is the only -3. And then last but not least, we don't have to know any of the -4s, but our one and only positively charged polyatomic is ammonium. So again, acetate, and I may be doing these out of order. Acetate, iodate, nitrate, hydroxide, and chlorate. Those are the 5 with a -1. Carbonate, chromate, sulfate. Those are out of the -2. -3 is phosphate, and the last one is ammonium. So again, if you don't have those memorized, make flashcards. And again, one side put the name, the other side put the formula with the charge. You need to know the charges. Okay? All right. Also, be sure to have your periodic table out, because we'll be using that to reference these quite a bit. So always have your periodic table out. And let's get started. So here is the polyatomic, and I'll blow this up, and I'll work out the evens again. So we'll move that over. The last worksheet that we worked out together, I gave you instructions on show the charge as well as the formula. So keep doing that. It's a good habit to get into, especially since we're starting to venture into some new territory here. First and foremost, you recognize a polyatomic when it ends in ATE. Okay. Notice that when what we did last time, we ended with IDE. If it ends with an IDE, unless it's hydroxide, you're looking at one of these nonmetals. Now notice hydroxide. You might be tempted to write a hydrogen there, but that's where it changes for you. So OH is hydroxide, it's not just a hydrogen. Okay? So if it ends in ATE, you're looking at a polyatomic. That is the first heads up that you need to recognize. If it ends in IDE, other than hydroxide, you're looking at the periodic table for your nonmetal. But if it ends in ATE, use this. Okay? All right, so looking at the first one, we have calcium, and again, calcium is in group 2A, don't forget that. So calcium has a +2 charge, and nitrate, again, if you don't know, pause the video, take a look at what the charge is, it has a -1 charge. So this does not equal 0, so we need to balance the charges, just like what we did the last time, and we'll do that every single time. So what that means is I'm going to need 1 calcium and 2 nitrates. So when writing this out, you have calcium, and nitrate is NO3 with a -1 charge. Since it has a -1 charge, we need 2 of those. Now remember, the only time we ever use parentheses is when we need to show more than 1 polyatomic. If we need to show more than 1 element, you never use polyatomics. Parentheses are for polys. Parenthesis, poly. And you only use it when you're showing more than 1 poly. So what we don't do is put a 2 there. Okay, we need 2, but we don't do that. Even if the polyatomic doesn't have a subscript, we still use parentheses. So be sure that you actually wrap that up in parentheses. So calcium nitrate is Ca parentheses NO3 close the parentheses 2. Okay. So let's look at, oh shoot, I wasn't supposed to do number 1. All right, looks like I'm going to do the odds here. So let's look at number 3, aluminum acetate. Okay. Again, find aluminum. So aluminum is on your periodic table, has a +3 charge. Okay, so again, write the charge above. Acetate, it's 1 of your 10 that I want you to memorize. Pause the video, look it up if you're not sure. Acetate has a -1 charge. Does that equal 0? The answer is no, it does not. So that means we need to multiply that by 3. Okay, so aluminum, symbol is Al, acetate is C2H3O2 with a -1 charge, okay? And since we need to show 3 of those, we're going to wrap the whole thing in parentheses and put a 3, okay? So aluminum acetate, we have 1 aluminum because it has a +3 charge. Each acetate has a -1. We need 3 of those. Number 5, silver chlorate. Silver is located right here, but it only has a single oxidation number, which is +1. So we want to make sure that we put the +1 charge on there. Chlorate, again, it ends in ATE, so you know you're looking at a polyatomic, and it does have a -1 charge. So we are good. So just write out the formula. So silver is AgClO3. No parentheses anywhere. Do not put parentheses on this formula because we don't need to represent more than 1 ClO3 or chlorate. Looking at number 7, calcium carbonate. So calcium, again, group 2A, has a +2 charge. So make sure we write our +2. Carbonate, again, it ends in ATE, so you know you're looking at a polyatomic. Carbonate has a -2 charge. Makes this nice. So the formula for calcium, Ca, carbonate, CO3 with a -2 charge. Since we have the same charges, we're done. All right, let's look at number 9. Okay, so back up to the top, swing it on over. Ammonium phosphate. Now, ammonium is acting like a metal, but you're not going to find ammonium on here. So don't go looking and go down to the AMs because that's americonium. That's not ammonium. So ammonium, by its nature, acts like a metal because it has a collective charge of +1. So we know that ammonium has a +1 and it is a polyatomic. It doesn't end in ATE. Only the polyatomics that are non-metals end in ATE. But ammonium has a +1 charge, and that's our only metal that we care about that is a polyatomic. Phosphate ends in ATE, and we know it has a -3 charge. If you don't, memorize the flashcards. So is this balanced out? The answer is no. So we need to multiply that by 3 so that the algebraic sum equals 0. So when writing this out, ammonium is NH4, and phosphate is PO4. So since we only need to show one phosphate and 3 ammoniums, wrap it up, put it on. Okay, so ammonium phosphate looks like that. Again, we're showing parentheses because we need to show more than one polyatomic, which is ammonium. Looking at number 11, magnesium nitrate. Okay, so magnesium nitrate, again, magnesium's group 2A, and I think we already did a magnesium or a nitrate already. So +2, nitrate, again, ends in ATE, has a -1 charge. That means we need, or equals 0. So how many nitrates do we need? Good, 2 of those. And magnesium and nitrate again is NO3. Since we need to show 2 of those, make sure that we wrap that up, put a 2 on there. Okay. So magnesium nitrate, Mg, parentheses, NO3, because we need to show 2 nitrates, 2. Number 13, aluminum carbonate. Again, aluminum has a +3 charge. Carbonate, we should know what the charge is. So aluminum is a +3. Carbonate is a -2. Does that equal 0? I'll tell you, no, it does not. So we have one of those scenarios where we have a 3 and a 2. We don't have a common variable here, so we need to multiply this by 2 and this by 3. So when we write this out, again, aluminum is Al, and then carbonate is CO3. Recall that we have our multipliers here. If you need to show more than one polyatomic, put it in parentheses and put a 3 there. Now, keep in mind that that 3 does not mean that we have 3 CO3s. That's why you put it all in parentheses and then put a 3. The aluminum, we need 2 of those, so put a 2 there. So this formula, aluminum carbonate, is Al2, parentheses CO3, close the parentheses, 3. Number 15, barium iodate. Again, barium is located in group 2A, right here. So barium has a +2 charge. Iodate, again, ends in ATE. Iodate has a -1 charge, very good. So that means that we need to multiply the iodate by 2. And when we write this out, barium, capitalize that, iodate, so that when we go ahead and solve, put your parentheses around it and a 2. So barium in parentheses, IO3, close the parentheses, 2. Okay, and that looks like the last one for that one. So now what we want to do is we're going to name the following ionic compounds from the formula. So now we're going to work in the opposite direction. So we now have our balanced formula here. We want to write the name for that. Probably not a bad idea, just as you're working these out, to write the charges above, just so that you can get the practice to make sure that these are actually balanced. Not a bad idea. So we had calcium, Ca. Okay. So calcium, spell that right. Calcium and CO3 is carbonate. And again, we don't need to do anything special when indicating how many we have. So number 1 is calcium carbonate. Number 3, we have 3 potassiums because phosphate has a -3 charge. So recognizing PO3 has a -3 charge. So if you wrote the charges above that, you'd have -3. And how many phosphates do we have? Very good. We only have 1, but we do have 3 potassiums. So that does equal 0. So in this case here, we have potassium, and the PO4 is a phosphate. Okay. So potassium phosphate. Okay. Looking at number 5, here we have barium, and again, barium is located in group 2A, so it has a +2 charge. ClO3 is a -1 charge, which is chlorate, and the reason why we have 2 is because we need that equal 0. So we have barium, and chlorate. Okay, so barium chlorate. Number 7, I think it's easier to go from the symbols to the name, but hopefully you think that as well. All right, here's a fun one. Looking at the zinc. Again, zinc is, even though it's a transition metal, it only has a single charge of +2. So if you're like, ooh, I wonder why there's a 3 there. Well, remember, what is the charge for a phosphate? That's right, -3. So that means that we do need 3 of those and 2 of those to equal 0. Okay? But again, when naming it, you don't have to worry about the charges, but it's good practice just to make sure that if I gave you the name, that you could write this out. So in this case here, we have zinc and phosphate. Okay. Number 9. All right, we have 2 polyatomics here. And again, NH3 is ammonium, and it has a +1 charge. Phosphate's a -3. That is why we have 3 ammoniums, so that all equals 0. Okay. So ammonium phosphate. So let's take a look at the other side. Okay. So where are we at? Number 3. So here we have zinc, again a transition metal, but it only has a +2 charge. So we're okay to use that for right now. And IO3 is iodate, that's why there's 2 of those. Okay. So charges are balanced, +2 -1 times 2. So zinc iodate. And again, you don't have to worry about indicating the charges because we know the charges, or you should know the charges. Number 12, you have K, which is potassium, group 1A, and NO3 is nitrate, so potassium has a +1, nitrate a -1. So we have 1 potassium and 1 nitrate. We don't have 3 nitrates because there's no parentheses. So when writing this out, so potassium and nitrate. Okay. And again, it's a 1-to-1 relationship there. Wait a minute, why am I doing evens now? Oh, well, that's interesting. Oh boy. All right, so looking at number 14, looks like I'm doing different ones there. Number 14. Actually, let's get back on track. Let's go with the odds since that's the way I started. So you had a bonus one there. So number 13, Na. Again, group 1A, which is sodium, has a +1 charge. And SO4 is sulfate. So if you're checking the charges, sodium has a +1 and sulfate's a -2. That is why there are 2 sodiums and only 1 sulfate. Again, no parentheses. So in this case, we have sodium sulfate. Okay. So sodium sulfate. All right, number 15. Finding it on the periodic table. Ba, right here, group 2A, so it has a +2 charge. And the ClO3, we just did one like that a second ago, has a -1 charge. That's why there are 2 of those, to balance out the charges. So in this case we have barium, and it's chlorate. Okay, so barium chlorate. And then number 17, the last example, and I hope this has been helpful. Magnesium, again, group 2A, so it has a +2 charge. And the PO4 is phosphate with a -3 charge. So we have +2, -3. That's why we have a 3 and 2 there to balance those charges out. 3 and 2. But again, when writing ionic compounds, we don't need to know that to write the name. So we have magnesium, magnesium phosphate. Okay? And again, the hardest part about working these types of problems out is memorizing the 10 polyatomics. And the reason why those 10 are special is because those are the 10 polyatomics that you'll use on the AP exam. Hope this was helpful.